Hello AP Calculus students! Today we will be learning how to calculate the area under the curve by using geometric figures and their basic area formulas. Before we get to the calculus part, let us refresh our minds by reviewing the area formulas of these shapes. When finding the area of a rectangle, you must use the formula base times height. The rectangle given has a base of 4 and a height of 6. Once you multiply your base and the height, you should end up with an area of 24 units square. Remember, it is substantially important to use the correct units, therefore do not forget to use unit square when solving for area. Finding the area of a square is simple as well, since all you have to do is identify the value of one of its sides and square it. Since the square given has a side length of 4, you should end up with an area of 16 units square. The formula to find the area of a triangle is the same as that of a rectangle. The only exception is that you must remember to divide the product of your base and height by 2. Since the triangle in this example has a base of 4 and a height of 3, you should end up with a product of 12 and an area of 6 units square after dividing it by 2. When finding the area of a trapezoid, you must remember to identify the value of both base 1, base 2, and the height. You will need to add your two bases, then multiply your sum by the height, and divide your final product by 2. In this case, you will end up with a sum of 6 after adding 4 and 2, a product of 18 since the height of this figure is 3, and a total area of 9 units square. Lastly, when it comes to finding the area of a semicircle, you must first identify its radius and square it since its area formula is pi r squared divided by 2. It is greatly important that you remember to divide your product by 2 since you are finding the area of a semicircle and not the entire circle. Since this circle has a radius of 2, you should end up with an area of 2 pi units square. The problems that we will be solving will be in the form of an integral, which is the pink symbol right here. And the a and the b of your integral represent the point A from which your interval starts at to point B where your interval ends, which is the starting point and the end point of the area that you are trying to find under the curve. Lastly but not least, you have your integrand, which is the function to which the graph belongs to. And you have your dx because the function is being written in terms of x. So the next problem that we will be solving will be in the form of the integral from point 2 to 6 of the function f of x dx. For our first problem, we are given the integrand from 2 to 6 of f of x dx. This integrand tells us that we need to calculate the area under the curve of f of x from the x value of 2 to the x value of 6. The first thing that you need to do is identify the shapes that make up the graph of f of x. Here we are given a rectangle and a triangle. After identifying your shapes, you need to identify their values. For the rectangle, you have a base of 4 and a height of 3. And for your triangle, you have a base of 4, which is shared with the rectangle, and a height of 2. Now that you identified your shapes and the values, you need to remember what formulas you need to use for each shape in order to find its area. For the square, you need to use the formula base times height, and for your triangle, you must use the formula base times height divided by 2 in order to find its area. Using the values that you found, you can now plug them into your formulas. For your square, you had a base of 4 and a height of 3. And for your triangle, you had a base of 4, a height of 2, and you must remember to divide by the constant of 2. 4 times 3 is 12, and 4 times 2 is 8, divided by 2. Now that you have found this, you can finally solve, which is 12 plus 4, and it ends up giving you a total of 16 units square for the area of f of x from the x value of 2 to 6. Now for our second and last problem, we have something a bit more different, since the interval of your integrand no longer goes from a positive x value to another positive x value. Now the interval for your integrand goes from a negative value to a positive value. Despite this change, you must still follow the same steps in order to calculate the area under the curve formed by the graph of f of x. The first thing that you must do is identify the shapes. You have a semicircle and you have a trapezoid. Now that you identified your shapes, you must identify the values. For the semicircle, you have a radius of 1.5. And for your trapezoid, you have base 1, which is 7, base 2, which is 4, and a height of 4. Now that you have identified your values and the shapes, you know that you are going to have to use the formula pi r squared divided by 2 and base 1 plus base 2 times the height divided by 2, since you are finding the area of a semicircle and a trapezoid. The next step is to plug in your values. So for your radius, you have the 1.5 squared, and for your trapezoid, you have base 1, which is 7, base 2, which is 4, and your height, which is 4. But the most important step that you must not forget is to put a negative sign in front of the area for the semicircle. The reason for this is that your semicircle is under the x-axis. Therefore, it has a negative area and not a positive. The trapezoid still continues to have a positive area since it is on top of the x-axis. The next step to do is to solve. When you take the square root of your radius, you get 2.25 pi divided by 2. Don't forget the negative once again. And for your trapezoid, 7 plus 4 gives you 11 times 4 divided by 2. After dividing, you get negative 1.125 pi, and you get 22, which in the end you get a total area of about 18.466 units square. It is very important to remember that for calculus you must always round to the third decimal. So in the end, the area for the curve of f of x from the interval -4 to 6 is 18.466 units square.